time to watch uh, previous semester video that I have actually put in my YouTube channel as well. Okay, and okay, we refer back to this. Okay, yesterday we stopped at fixed end moment, right? Fixed end moment. Fixed end moment. And you all come from diploma. Means that you have actually learned this previously. Okay, during your diploma time. Okay, maybe 2 or 3 years ago. Okay, so this is the time for you to enhance back your understanding. Okay, make it clear because this is very very important. MDM ni uh, is very important because in design. Under design nanti next semester you will be taking design courses, and in design you need uh, to use this basic, okay, to draw the bending moment diagram, because we identify the crack, okay, in the beam by using the bending moment diagram. Okay, so normally when you learn structure analysis, semua ada reason. Okay, why I need to calculate reaction, why I need to calculate internal forces, why I need to calculate displacement. So you have to have the answer of all these questions. For example, how I calculate displacement. Displacement, I calculate using unit load method or principle of virtual work. So how to do that? So by using formula, and inside the formula, I need to know the internal forces. Internal forces. How to calculate internal forces? After calculate reaction, then only we can calculate internal forces. Internal force by, kalau for beam we write the moment equation and we replace x value and we get the moment value. So same goes to truss. The internal forces in truss is member forces or axial forces in member, and to calculate that we have to know the reaction. So yesterday I mentioned about these three important things, important things as the summary of what you have learned. Okay, what you have learned, start from static, and then continue with solid mechanic. You learn about beam, how to calculate reaction in beam, how to write moment equation, shear equation, and then followed by determinate structure. You learn how to calculate reaction again in frame. Calculate reaction in frame, apply equilibrium equation. Calculate reaction in truss, apply equilibrium equation, and then calculate reaction in arch cable. We apply equilibrium equation. And after that, you also learn how to write shear equation, how to write moment equation. Why we need to do that? Because shear forces, shear forces and bending moment is actually internal forces in beam, in frames. And in truss we calculate member forces. Member forces is internal forces in truss. So why we need to have these internal forces? Because to calculate displacement, we need to know internal forces. We need to know internal forces. And of course, analysis of determinate structure is quite straightforward. Okay, very quite short as well. Okay, since all that covers determinate structures only, but this time this is indeterminate structures. So indeterminate structures, if you realize kan, topic for this course based on method, and inside each method tu there are many type of structure that we need to analyze. For example, in this topic moment distribution method. Okay, in this topic moment distribution method, there are two types of structure that we are going to analyze: beam as well as frame. Beam as well as frame. So we need to calculate member and moment. What is actually member and moment? Member and moment is internal moment. Internal moment is internal forces. Internal moment in beam and in frame. In beam and in frame. Why we don't need to calculate this is internal moment. Why we don't consider thrust in moment distribution method? So we always have question and we have to find the answer of each question. So it's good you have question in your mind, because if you have question means you start to understand. If you don't have any question to ask, yang tu yang saya worry. Because kalau you dalam kelas, you diam dan tak tanya langsung soalan, dia ada dua je. Tapi most probably you tak faham apa yang you belajar. That's why you don't have question. Because if you have question means that you start thinking. Means that you start to understand. Okay, so feel free to ask anything. Okay, kita boleh together find the answer. If I don't have the answer inside this slide, okay, if I do not know the answer, we can together find the answer, because the answer you can find everywhere. Okay, you boleh Google je kan? You boleh Google je. Why I need to calculate moment distribution method? Ada ramai yang akan bantu you jawab. Dalam Google tu, you search je kan. Why I need to calculate bending moment diagram. Kat situ ada ramai practitioner yang dia rajin jawab soalan ni. Okay, jawab soalan ni, dan yang mana orang lain dah tanya, you boleh find the answer as well. Okay, so bukan saja-saja ramai student bila dia buat, contoh bila belajar beam kan, MDM, bukan beam, MDM yang ni, bila buat beam dulu, masa solid mechanic, sampai draw bending moment diagram. Tapi masa exam, ramai yang still tak boleh draw the right one. Okay, tapi kena ingat ya, moment diagram, bending moment diagram is important for you in the design later on. Design perlukan bending moment diagram. There is a reason why you need to know bending moment diagram. So as civil engineer ni, bending moment diagram you kena master. Nak tak nak you memang kena master, sebab dia akan relate balik dengan nanti course next semester you akan ambil design, so you nak identify kat mana maximum crack kat mana. So semua tu from bending moment diagram. So bukan saya sajalah, maksudnya saya selalu ajak my students untuk think backward. Think backward. Sebab think backward means you want to find the answer. You want to find the answer, you want to understand what you learn. Think backward. Tetapi kalau you do forward ni means you remember. Dia lebih kepada macam okay, step 1 buat ni, step 2 buat ni, step 3 buat ni. Yang tu remember. Tapi kalau you think backward, yang ni maksudnya you start cari reason. Okay? Means that you dah nampak, you punya aim dah nampak. You punya aim dah nampak. So bila you dah nampak, in order to achieve your aim, ada berapa step yang you perlu buat, and apa yang you kena sediakan untuk setiap step tu. Means that yang tu think backward. Tapi kalau you terus remember every step without knowing what is your aim, yang tu buang masa nama dia. Okay? So memang kena set aim dari awal. So you have to know MDM. I learn how to calculate member and moment. What is member and moment? Member and moment is internal moment. So that is why from the value that we will get from table, we can draw the bending moment diagram directly. That is why ramai student yang bila dah lepas this course, dah ambil this course, masuk subjek design, ambil subjek design, patah balik tanya macam mana nak guna, macam mana nak belajar, nak belajar balik macam mana nak buat bending moment diagram. Bending moment diagram. And memang akan guna balik. Kalau nanti you involve dengan structure punya company, structure engineering company, as structural engineer, you memang akan jumpa lagi MDM. Okay, moment distribution method. It is very, very important. Bukan saya saja belajar je yang ni. Okay, very, very famous topic in the world. Okay, bukan kat Malaysia je, in the world. So, you boleh tengok dekat dalam YouTube tu. Dekat dalam YouTube tu, Dr. Structure, dia ada banyak yang dia bincang on moment distribution method. Ada banyak lagi video-video in YouTube yang you boleh refer. Okay, yang you boleh refer. And my video as well lah. As well, you boleh tengok. Okay. So in MDM semalam kita dah discuss about sign convention. Sign convention for MDM clockwise positive. Sign convention for MDM clockwise positive. Okay, as suggested by Hibler means that sign convention for MDM ni is based on assumption. Okay, sebab ada satu lagi reference book written by Aslam Kasim Ali yang tu kalau you jumpa buku kalau you ada buku tu atau lepas ni you cari material from Google, you tengok sign convention dia balik, bukan salah, maknanya sign convention yang dia refer tu adalah counter clockwise positive. Counter clockwise positive. So buku Aslam Kasim Ali ada dekat library. Okay, untuk MDM dan juga slope deflection method. So assumption that has been made for MDM and SDM sign convention is counterclockwise positive. Okay, yang kita follow adalah textbook Hibler, textbook RC Hibler. Okay, clockwise positive. Clockwise positive. Sign convention ni pun ramai student pening. So ada sign convention yang you must follow. Ada sign convention yang you can assume. Okay, you can assume. Yang ada yang you must follow tu pun it is based on assumption juga, tapi kena consistent. Dia sebab consistent tu lah you kena follow that sign convention. Okay, sign convention. So as engineer, civil engineer, structural engineer, sign convention is very very important. And sign convention ni negative positive normally referring to sign convention. Okay, negative positive. So the beauty of structural analysis ni bila kita do calculation, so all the calculation tu can be illustrate, can be representing by diagram. So ada diagram dan ada justification. Kenapa diagram macam ni, kenapa direction macam ni. So that is the beauty of structural analysis. So ada reason kenapa setiap step yang kita buat tu. Okay, so yang tu sign convention. So jangan confuse dengan sign convention for equilibrium equation. Jangan confuse dengan sign convention for cutting section. Okay, jangan confuse dengan sign convention for fixed end moment sebab semua tu different things. Okay, so yang ni kita assume that clockwise moment, that act on member is positive. Positive. So kita peganglah positive clockwise. Positive clockwise. And then kita semalam sempat bincang on fixed end moment. Fixed end moment. Nampak kan dekat screen fixed end moment. So fixed end moment also sign convention. Has sign convention for the moment. But the sign convention for fixed end moment is not assumption. It based on the behavior of the beam. Okay, of the element. Okay, due to loading, macam mana dia deflect, macam mana dia bend. Okay, so fixed end moment. All reaction memang konsep dia sama macam inertia punya konsep. Dia mesti nak counter back. So that direction of counter back direction tu is representing the behavior of fixed end moment. So yang ni dah explain semalam. Okay, fixed end moment means that dalam analisis nanti fixed end moment kita akan pakai lah for the first member end moment in the table will come from fixed end moment. Okay, and then in moment distribution method, so in order to calculate the member end moment, the internal moment or member end moment, okay, we have to understand about the stiffness factor. The stiffness factor. Stiffness, the symbol is K. Stiffness, the symbol is K. It comes from, actually this K is very very important. That is why K ni kan, K ni come from the word stiff. Stiff ni opposite with flexible. Okay, stiff is one of the important parameter that okay, for the material, for each structure. So ada a K ni is very very important to control displacement. So displacement ni dia akan relate dengan this K, dengan K. Okay, you boleh tengok video yang kelas tadi. Saya ada bincang K ni, asal usul K ni come from where. Okay, K. Okay, and K in this topic moment distribution method is called as member stiffness factor, and the formula is given as 4EI over L for far and fixed. Far and fixed. Okay, far and fixed. 4EI over L. We also have the other formula to calculate K. It is 3EI over L for far and pin or roller. Far and pin and roller. Okay, for the first example, kita focus on this one first. Okay, far and fixed means, okay, if we have continuous beam, if we have continuous beam, okay, if we have continuous beam like this, macam ni, okay, far end refers to these two. Ni A, B, ni A, B, C, D. Okay, far end refer to A, refer to D. That is far end fixed. Okay, far end fixed. So K, formula dia 4EI, 4EI over L ni is for far end fixed. Kita tak mention about these two. These two is internal. Internal support, and internal support is always assumed as fixed support. So that is why automatic we can get K for BC equal to 4EI over L. That is why bila the term is far and fixed, far and roller, yang tu term for and condition, and now is referring to A, referring to D, because we can also have beam like this. Roller, 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 or pin, doesn't matter. Okay, pin dengan roller ni samalah sebab kita tak count pun the axial deformation. Okay, yang ni far end dia kat sini A, B, C, D. Far end in this case referring to D, referring to A. Far end. So KAB we use 4EI over L. KBC we use 4EI over L. But KCD we don't use 4EI because far and fixed the formula is 3EI over L. So yang ni kita pakai 3EI over L for end pin or end roller. Far end. Okay? Tapi for the first example, kita fokus on yang ni dululah. Yang A pun fix, D pun fix. Okay. So dia ada, yang ni lah dia kan. Dia ada detail explanation dalam textbook, ada derivation. Tapi derivation tu tak tanya dalam test, dalam exam tu tak tanya. So don't worry, just focus on how to calculate right K. Okay, the right K. Lepas tu dia ada joint stiffness. Joint stiffness ni total K. Joint stiffness is total K. Okay, why we need to have joint stiffness? Because we want to calculate distribution factor. Okay, we want to calculate distribution factor. And distribution factor ni, we will use it to distribute moment. We will use this distribution factor to distribute moment. And the moment that we distribute is joint moment. Joint moment. So nanti kita nak calculate distribution, kita nak calculate end moment. Kita nak calculate end moment, kita akan gunakan moment which is called as joint moment times with distribution factor. So kita akan ulang this process again and again until the moment reaches zero value. So the moment that we distribute yang ni, moment that we distribute, okay, in this case yang 2000 ni nama dia joint moment. Yang 0.4, 0.5, 0.1 ni nama dia distribution factor. Ini proses yang berlaku dalam table. Okay, dalam table. So yang ni joint moment. Moment ni joint moment. Joint moment. Okay. Lepas tu dah tahu how to calculate K, how to calculate distribution factor, how to calculate fixed end moment, kita dah boleh start start calculate member and moment, okay, dalam table. So dia in table form, okay, kita tengok straight to example in the textbook. Okay, so this is the question. This question is taken from example 12.1. 12.1. So RC Hibler, Determine. Determine internal moment. So internal moment equal to member and moment. Internal moment is internal forces. Okay, member and moment is internal moment. So by looking at this diagram, okay, this beam has three members. Three members, A, B, B, C, C, D. So how many member and moment? How many internal moment that we are going to determine? How many? How many? Semalam kita dah discuss.
Tiga.
Tiga members. Member and moment ada how many?
6 ada.
6. Okay, we have 6. We have 6. We will calculate 6 member and moment. We will calculate 6 internal moment. Start from AB until DC. Okay, each member has 2N. So has 2N, so dua dia jadi 6. Okay. Okay, so 6 ni kita akan terus create dalam table. So in the first step inside the table, because we have to know that inside the table, proses yang kita akan buat adalah kita akan distribute moment. How to distribute moment is by by considering like this. Okay, join moment times distribution factor. Yang tadi saya tunjuk tu. It is join moment. Ini proses dalam table. Join moment kali dengan distribution factor. Ini pada step yang nama dia distribution. Join moment times distribution factor. Yang ni proses dalam table yang kita akan ulang dan ulang. Okay. Dalam table tu. Sampailah the last distribution kita dapat 0.0 something. Baru kita stop distribution. Dia proses yang berulang-ulang. Okay. Pada level distribution dalam table, kita akan distribute moment. So the moment that we distribute is joint moment. Remember yesterday I have told you that we have member and moment that we get from fixed and moment, and then we have to change sign because joint moment is opposite with member and moment. Diagram semalam tu yang ada saya draw diagram for moment for joint, moment for member. Moment for member is clockwise, moment for joint is opposite. Okay, so yang tu adalah proses dalam table lah. Okay, so dalam table kita akan ada distribution. So distribution joint moment times distribution factor. And after that, number 2, step after distribution is called as carry over. Ini 2 step dalam table carry over. Step important step dan dua ni je, distribution carry over, repeat again, distribution carry over, repeat again, distribution carry over. So in carry over apa yang kita akan buat is kita akan moment tadi tu n moment, member n moment divide by 2. Member n moment, okay, divide by 2. Yang ni untuk n fix je boleh. N fix. Internal fix lah, lepas tu n fix. Dia bukan divide by 2 je. Divide by 2 ni untuk semua. Okay, dia divide by 2 ni come from what we call as carry over factor. Where carry over factor for n fix is equal to 0.5. And carry over factor for n pin or roller is equal to 0. Okay, carry over factor ni ada two types. Dia akan refer back to for n condition. For n fix, for n roller or pin. Okay, remember for n referring to kalau A, B, C, D, for n refers to A, refers to D. Because B dengan C, internal is always fixed. Okay, so we have two carry over factor, 0.5 for n fixed. That's why for this example, semua carry over ni, member and moment at each, dalam tu ada banyak cycle, at each cycle tu kena divide by 2, representing times 0.5. Okay, 0.5. Sini yang kita akan buat kejap lagi dalam table. Okay, dalam table. So kita start from ni, yang buat dengan group tadi tak apa, kita buat baru. Okay, kejap dia refresh. Okay, apa yang you nampak kat screen? Is it Excel?
Ya, madam.
Okay, so kita buat yang baru. Yang ni, kejap Okay, so this moment distribution method easy to apply because we can formulate it in the tab in Excel. So by program it in Excel, so we can get the moment easily actually. Okay, so this is the beam. This is the beam. There are 6 member and moment. So we will create table first. Table tu must have six column for each member and moment. So start from AB lah. AB, AB, and then we have, nampak tak? Is it okay? Besar ni boleh nampak dekat screen?
Boleh, madam.
Boleh Okay. So mesti ada 6 tau sebab dia kena equivalent to member and moment, 6 member and moment yang kita nak calculate. So AB, BA, BC, CB, DC. Kejap, ke bawah. Okey, yang ni. Okay, ada how many join? We have join A, right? We have join A. We have join B, combine BA and BC. Okay, join B, combine BA and BC. B tu ada BA, B tu ada BC. So join B, BA plus BC. Okay, so this is join B. Okay, so we have join C combining CB, CD. Join C, CB, CD. So it is C. Okay, join C and the last one is D. Okay. So there are 3 members, 4 join, 6 member and moment. Okay, so K pun saya nak straight away calculate inside the table. Okay, kalau nak tengok detail how to calculate, how to do stiffness calculation, distribution calculation using slide, you boleh tengok using, mana dia tah? Okay, kat sini dia tunjuk, okay, K and distribution factor. K ni macam yang tadi K is equal to 4EI over L for far and fixed. So example ni semua far and fixed. And distribution factor is K divided by total K. Distribution factor is K divided by total K. So there are 3 values lah representing 3 elements. So yang ni lah 3 element. Okay, 3 element. And then distribution factor there are 6. Distribution factor there are 6. Okay. And distribution factor for A, B, and DC. At A and at D means A, B, and DC. This is equal to 0 because distribution factor ni dia per dengan infinity. That's why dia dapat 0. So special for n fixed. Just remember the value, the distribution factor is all 0. Okay, distribution factor for the rest. Okay, join must equal to 1. Total equal to 1. Total must equal to 1. Distribution factor ni dia sebenarnya equal to 1 except n fixed. Yang lain-lain semua equal to 1. Yang ni ada 2 ni. Dia tambah 2 tambah 0.5 ni. Dapat 1. Yang ni pun tambah 2 ni dapat 1. Total is 1. Tapi 1 by 1 dia ada separate value lah. Yang kita tambah akan dapat 1. Okay, so yang ni. So saya nak terus jump to Excel. So kita tengok how to program this into Excel. Okay, kejap. Okay, the first step. Okay, the first step to do is to calculate K because K will be used in DF. Okay, DF tu kita akan guna dalam table to distribute moment. Okay, so saya akan terus letak K dekat sini. K. Okay, in terms of EI, so EI I put outside because bila kita calculate distribution factor, EI akan cancel. EI akan cancel, will be cancel. Okay, so remember KAB, KBA. One, AB and BA don't get confused. It is the same. Cuma kita susun dekat sini AB dengan BA representing N moment nanti. Okay, so tapi jangan confuse, jangan kata AB ni formula tak sama dengan BA, dia sama je. Okay, so yang ni we will use 4EI over 12. EI I have put sebelah K tu. So dalam ni I just program put the formula. It is 4 divided by 12. 4 divided by 12. So we get 0.333. Okay, so BCCB again the same element, the same member, and the length is also same. It is 4 divided by 12. Okay, and for member CD yang ni 2, okay, it is 4 divided by 8. Okay, this is how we calculate. This is how we calculate stiffness factor. Jadi kalau soalan nanti tanya calculate stiffness factor. Kalau you bagi dalam bentuk ni pun dah dapat full mark. Okay, dah dapat full mark. Okay. So from K we will calculate distribution factor. Distribution factor. DF. Okay, remember dekat A ni fix. Dekat A fix. D also fix. Okay, D also fix. So kita ada 2 fix N. So fix 0. Okay, fix 0. Don't confuse. Okay, dia 0 sebab infinity. Dia kan fix N. Bila kita analyze beam, mana ada satu structure beam macam ni je kan? So actually kita simplify. So in structure analysis ni apa yang kita buat is kita simplify structure tu. That's why kita macam take out one element, take out two element from the real structure, and then bila yang A dengan D tu maksudnya selepas A tu ada lagi. Selepas D tu pun ada lagi. So that's why the infinity. We do not know what which how many members actually and you just only take this out and then we analyze using structure analysis using MDM. Okay, so that is why A and D tu is not the end of structure. That's why formula to K tu divide by infinity. Okay, K is divided by infinity. That's why we get 0. So kalau N dia pin, N dia roller, we get 1 as the answer. Okay, kalau N dia pin, N roller. Okay, so yang ni 0, 0 doesn't matter. So yang lagi 4 ni we have to calculate. We have to calculate distribution factor. 1 by 1 actually. Distribution factor you cannot combine. Distribution factor must have 6. Okay, must have 6. So we have to calculate from formula K divided by total K. K divided by total K. Total K means joint stiffness. Joint stiffness factor. Okay, total K. Total means macam ni. Okay. Kalau nak cari DF for BA, the value is 0.333 is KAB. Okay. K for yang tu, okay, now kita nak cari K for joint B. Okay, for joint, kita combine these two value. This is joint stiffness. Okay, member stiffness satu ni. Kalau member stiffness, kan formula dia kan DF. Tak nampak kat situ sekejap. DF, formula dia DF equal to K divide by total K. Ataupun divide by KT. K divide by KT. Okay, KT. Distribution factor. Okay, total K. So K total maksudnya K total for each join. So B ni consists of BA plus BC. B consists of BA plus BC. So K for BA is 0.333. K for BC is 0.333. Yang tu join. So totalkan lah. Totalkan kita dapat 0.666 tu kan. Okay. So to calculate distribution factor for BA, so it is K 0.333 divide by total K. Total K is 0.333 plus with another 0.333 for member BC. Okay, for member BC, so we get 0.5. Okay, 0.5. So for BA BC, total must be 1. B means BA plus BC. Total must be 1. So what is the value for this? Total of these two must be 1. So what is the value? Yang ni.
0.5.
0.5. 0.5. It is 1 minus 0.5. We get 0.5. Or kalau kita nak calculate using formula, again, yang ni 0.333 divide by total. Total 0.666. Total dapat dari BA dengan BC. Okay, so we get 0.5 here. Okay, so same goes to CB. CB, join C ni dia ada dua. Join C ni dia ada CB, dia ada CD. So total K, okay, total K is CB plus CD. Means 0 point. Total K berapa? What is total K? Total K for join C. Total K.
0.8.
Yes, 0.833. Okay, so to calculate DFCB means KCB lah. Divide by total. Okay, total is 0.833. Alamak, kejap. This one divide by... Okay, we get 0.4. 0.4. So, yang ni automatic we know that this is 0.6. Sebab total 0.4 plus 0.6 must be equal to 1. Okay, distribution factor. So, soalan kalau tanya calculate distribution factor. So, bagi jawapan dalam bentuk macam ni, so dah acceptable. Okay, so next step is fixed end moment. Fixed end moment. Next step is fixed end moment. Next step is fixed end moment. Okay, fixed end moment ni, we ada the principle dia, we want to distribute moment to join. Okay, to join because member cannot carry load. We have to distribute to join. Okay, means that fixed end moment ni we only analyze, we only calculate the value whenever the beam is loaded. Okay, AB kosong kan? AB kosong. So there's no value for FEM. AB. FEM, here is FEM. Okay, FEM. So FEM for AB kosong lah sebab tak ada loading pun atas AB tu kan. Dan kosong dalam table ni tak payah tulis. Kecuali DF tu. Okay, kosong tak payah tulis. So leave it blank. Okay, we move to BC. So BC kita yang ni. BC, CB yang ni. Okay, yang ni. Okay, yang ni kita punya member BC. Okay, we have FEM BC, FEM CB. So yesterday I have explained why it is negative, why it is positive. Okay, negative, positive. So yang ni we get WS squared over 12. WS squared over 12, it is negative WL L squared over 12. get negative 240. Okay, we get negative 240. Remember, one negative, one positive, representing the behavior. Representing the behavior. So we get one negative, one positive, 240. Okay, so dekat CD, again dekat CD ada point load. Point load at the center. So refer to the formula. Point load at the center, formula for phase and moment is PL over 8. PL over 8. PL over 8 ni equivalent to 250 sebab length dia pun 8 meter, so we get negative 250 and 250. Okay, so this is fixed end moment for member CD. Fixed end moment for member CD. Okay, ada soalan tak for FEM ni? Do you have question for FEM? Do you have question for FEM? Diam means faham ke diam means tak faham? Okay,
Tak ada.
no question. Okay. So, okay, we have to understand the value inside this table in diagram. Okay, so remember that fixed end moment ni, fixed end moment is first member end moment in the table. Okay, first member end moment in the table. Fixed end moment. And don't forget, okay, everything inside this we can draw in diagrams to represent it. Okay. So yang ni. So that is why understanding about concept of joint moment and member and moment are very, very important. Okay, yesterday I have shown to you in diagram beside member and moment, which we assume as positive sign convention. Okay, moment, member and moment are all positive. Okay, clockwise. And we have another one called joint moment. And joint moment is always opposite with member and moment. So dalam table tadi tu, we have three members. Okay, we have three members. Okay, dalam table tadi we have three members. Mana pergi dah? Kejap. Ini. Ini. In the table. Okay, in the table we have three members. Okay, members. So the first member and moment come from this. Okay, UDL tadi tu, we calculate fixed end moment, and it is like this. And the value is 240 and 240 as well. So negative in the table representing this direction. Okay, that's why it is negative. Okay, so for CD we have another one. Okay, PL over 8 kan, this is 250 times PL times 8 divided by 8 equal to 250. So the moment, the fixed end moment for this beam, okay, like this. Okay, the value is 250, 250. Okay, so AB tu kosong lah. So this is A, B, sini C, sini D, sini D, silap. AB sini B juga. Ini BC, BC, CD. BC, CD. Okay, CD. A, B, B, C, C, D. Okay, beside members, we have join. And join always opposite with member and moment. Ini principle dia. Ini konsep dia. I don't want you to do it by remembering. Saya tak nak you buat analisis using MDM ni. You buat sebab you hafal dia punya step. Saya nak you buat, you know what is behind the table. Okay, means that you understand the process. Okay, the real process. Okay, so this is A, B, B, C, C, D. Okay, beside members, we have join. We have join. So join, kat sini join. Okay, kat sini join. Okay, wait. Okay, sini join, roller B dengan C kita tu. Sini B, sini C. Okay. Okay, so now I want to draw, okay, join moment. And remember, join moment opposite. So tengok pada B tu, okay, letak yang opposite direction. So this is 240. Okay, 240. 240. Okay, at C, opposite with 240 for member tu. Okay, dia ada opposite like this, opposite like this. Kejap. Opposite. Betul. Opposite. Okay, opposite. Dia kena opposite. Kalau yang C yang ni tadi, yang ni, dia positif kan? Yang satu lagi tu mesti lawan dia. Dia opposite. Join moment must opposite with member and moment. Opposite. Okay, yang ni 250, yang ni pun 250. So join moment yang ni. Join moment yang ni. Join moment. So yang ni join moment dia equal to join moment at B equal to positive or negative? Join moment. Positive. It is 240. 240 kilonewton meter. Okay, join C. MC. Join moment.
Negative.
Negative or positive? Yang ni 240. Yang ni 250. Negative or positive? Negatif ke positif? Negatif ke positif? Dalam bulatan tu?
Negatif.
Positif. 10. Positif 10. Positif 10 kilonewton meter. Kita tak tulis benda ni. Bila kita buat moment distribution method, terus pakai table tu, all this value inside the table. Tapi today saya nak illustrate, okay, behind the scene, behind the table. Okay, behind the table, this is the diagram. So this is the, okay, the things that you see in this table. Okay, so the first step is distribution. Tadi kan saya mention, dalam table kita akan repeat dua proses. Number 1 is distribution. Number 2 is carry over. Okay, so bila kita dah letak nilai FEM, the first thing to do is to start distribute moment. Okay, and we will start with distribution followed by carry over, repeat again distribution, carry over, until the last distribution. So this is distribution. So total moment at B. Dekat join sinilah, total moment dekat join. Dekat join B ni. Kan, total moment dekat join B. Kita nak guna untuk calculate moment baru dekat BA. Moment baru dekat BA. Okay, yang tadi first tu dah settle dah. First tu dah settle. Now kita dah calculate tadi join moment kan. Okay, now kita nak calculate distribution. Okay, distribution. Remember that the moment that we distribute is join moment, not member and moment. Jadi nilai yang kita calculate dekat sini, okay, join moment equal to, this is join moment, right? Sama tak dengan yang ni? Sama tak?
Sama.
It is 240, right? It is 240. Bukan negative 240. 240. Okay. So kali dengan distribution factor 0.5. Distribution factor. So we get positive 120. Positive 120. So I set all this into Excel, set formula so that nanti kita boleh continue next cycle tu by copy paste only. Okay, time with distribution factor. That is why MDM ni is very easy to apply. Okay, so we get 120 because the factor is 0.5 as well. 0.5 dia bahagi 2 je kan. So total ni dapat 0. Total ni mesti dapat 0 because moment at B must equal to 0. Dekat sini moment at B ni must equal to 0. Okay, moment at B. Moment at C equal to 0. Internal moment total must equal to 0. Separate dia ada value. Combine dia jadi 0. Okay, so total 0 plus negative 240 plus 120 plus 120 we get 0. Okay, move to this. Join moment. Join moment is 10. Join moment is 10. Yang ni, 10. 10 we get from the blue one, not the red one. The blue one, which is opposite with member. Okay, join moment opposite with member and moment. We get 10. Okay, we get 10. Kita tak nak you buat macam ni. 240 minus 250 kali 0.5 kali 240 minus 250 dapat negative 10. Negative 10 times dengan 0.4 dapat 4. Dapat 4 tukar sign baru letak sini. Dia bukan tukar sign. Tukar sign because of behavior tu. Okay, bila kita buat kan, kalau you still remember masa diploma belajar kan, yang ni tambah ni, kali ni tukar sign letak sini. So dia bukan sekadar tukar sign. Dia ada proses representing kenapa kita tukar sign tu. Okay, it is because the moment that we distribute is joint moment which is opposite with member and moment. Dapat 10. 10 ni belum distribute lah, belum distribute. This is just joint moment. Kali dengan distribution factor 0.4. Okay, we get 4. We get 4. Okay, repeat again the process. It is 10. Okay, it is 10. So how to get 10? Saya letaklah negatif kat situ kan to represent 10. Okay, to represent opposite condition. Times with factor 0.6. Times with factor. Okay, like this. Okay, so last one because factor is 0. Kalau factor is 1, kena kalilah dengan factor. Tapi yang the last value, 250 ni, opposite is negative 250. Negative 250 ni sebab kali dengan 0, that's why sini dapat 0. Tapi kalau sini pin for example, DF is 1, so kita still kena distribute. Okay, still kena distribute. Okay, so next step. after distribution is called as carryover. The factor is all 0.5 sebab all are fixed. Okay. And we must carry the value to opposite join. Carry the value to opposite join. Yang ni kena darab silang. Kena darab silang. Okay. Kena darab silang sini. Opposite join. Opposite join. Okay, means that between A dengan B, between B dengan C, between C dengan D. Carry to opposite join. Okay, so 120, when we carry, we divide by 2, we get kejap, 24 ni pula, kejap. 60. Okay, we get 60 ya, we get 60. Okay, we carry to opposite join. So kalau ada value sini, carry lah. Tapi sebab dia 0, so 0 do not need to write 0 in the table. Okay, so again yang tengah ni 120, we carry to opposite join. So we get 120 divided by 2. Okay, at CB. And then for BC, we get from 4. 4 divided by 2. So we get 2. Okay, and then last one, we get 6 divided by 3. 6 divided by 2. So we get 3. Okay. Clear yang ni? Darab silang ya. Dia ada boundary lah. Means dia ada boundary. Boundary dia tu dekat setiap boundary tu. A dengan B ada boundary. B dengan C ada boundary. C dengan D ada boundary. So kita cross boundary. Bila kita carry over times with the factor, dia mesti cross boundary. Okay, mesti cross boundary. Nanti saya tunjuk macam mana cara tulis, cara you nak tulis nanti. Supaya you tak confuse mana satu nak carry over tu. Okay, so kita finishkan yang ni dulu. Okay, ada soalan tak? These two process. Distribution carry over. Distribution carry over. Do you have question?
Question, madam.
Do you have any question? Okay, is it okay? Okay, yeah. Okay, so you need to repeat distribution again. And then repeat carry over again. And then repeat distribution again. And then repeat carry over again. And then repeat distribution again. And then repeat carry over again. And then repeat distribution again. Repeat. Okay, repeat these two process. Okay, repeat these two process. So each process tu dia akan refer to the upper value lah. Value yang ke atas dia kan. Dia ke atas dia. So akan ulang balik lah step tadi yang ni. Lepas tu kali dengan factor. Okay, ulang balik. Nanti tengok balik video ni macam mana kita proses tu. Sebab bila saya formulate saya set guna Excel, kenapa tadi nampak saya masuk formula tu kan? Sebab saya nak copy and paste only. Copy, paste. Okay. Okay. So this is for the second cycle. Nanti kita double check. This is for the third cycle. Okay. Lagi satu. Okay, lebih kurang lah. 0.3, 0.3. So the last must be distribution. So this is the table. This is the table. Kita tengok step yang tadi ni, step dekat sini. Tengok step dekat sini. Dekat sini ya, kita tengok step dekat sini. Okay, distribution carry over. Okay. Betul tak yang ni dapat 1 negative 1 and negative 1. It is negative 2 times with factor 0.5, we get negative 1, negative 1. Isn't it? Okay, because total yang ni, this is the total. Okay, this is the total and join moment opposite. So it is negative 2. Negative 2 times with factor 0.5 dapat negative 1, negative 1. Okay, ni settle. Okay, same goes to this total. Total is here. Total is 60. Opposite is negative 60. Negative 60 times with factor 0.4, we get negative 24. Negative 60 times with factor 0.6, we get 36. We get 36. Any question? Any question? Okay, okay. So then we carry over again. Carry over must cross boundary. Carry over must cross boundary means this, okay, is the boundary. Okay, so we get negative 0.5 and then we get negative 12 come from negative 24, negative 0.5 again, and then negative 16 come from negative 36. Second cycle. Okay, second cycle. Repeat the third cycle. The third cycle yang ni. Ni satu kan, ni dua. Okay, the third cycle. The third cycle, it start from ni. Total moment. Okay, joy moment is positive. Joy moment is positive 12. That's why we get 6 and 6. 6 and 6 because factor is 0.5. And then dekat C, total moment 0.5. Positive. That's why the answer is 0.2 and 0.3 because the factor is 0.4 and 0.6. Okay, so that is the second cycle. Okay, and then move to carry over. Carry over. Cross boundary. Carry over. Cross boundary. Cross boundary. Cross boundary. Okay, cross boundary. We get 3, 0.1, 3, and 0.15. Repeat lagi. Repeat lagi distribution number 4. Repeat the same thing. And then carry over. And then repeat lagi. So bila nak stop, basically 5 or 6 times. 5, 6, 7 times will be enough. Okay. When we meet 0.0 something, then we may stop. Okay, we may stop. So table dah siap. So now we will calculate member and moment. We calculate member and moment. Member and moment, senang je nak calculate. Kita totalkan from fixed and moment until the last distribution. Okay, totalkan all the moment value row by row. Row by row, start from the first distribution. Start from first moment, that is fixed and moment until the last moment. Okay, totalkan all. So we get, okay, nampak tak ni? So this is the answer. Okay, this is the answer. So this is end moment. This is moment lah, member and moment. Member and moment. Okay, please look at this. These two value. Okay, and then these two value. Okay. Okay, these two value. Okay, equal to 0. Equal to 0 because MBA plus MBC equal to 0. This equation, okay, this equation ada pada slope deflection method. Okay. And then another one, MCB plus MCD equal to 0. We must get 0. Kalau tak dapat 0 means ada something wrong somewhere. Okay, mesti dapat 0. Okay, mesti dapat 0 unless ada applied moment dekat join. Then only tak dapat 0 tapi equal to moment that you apply. Okay, that we apply. Okay, tapi yang basic macam ni je lah. So get 0. So that is why we get 1 negative, 1 positive. Okay, so the moment for AB, AB is 62.475. Okay, 62.475. Okay, saya ambil nilai ni. Gimana dia tadi? Yang ni kan? So, yang ni. Copy. Okay, I want to put here. Okay. Ada soalan tak? Do you have any question?
Madam nak tanya madam.
Okay.
Yang carry over dengan distribution ni selalunya berapa banyak nak kena buat sampai boleh dapat kosong tu?
Biasa 5, 6, 7 macam tu. Kadang-kadang 5, kadang-kadang 6, kadang-kadang 7. Bila, macam yang ni kan tadi berapa kali? 5 kali kan? 1, 2, 3, 4, 5 dah dapat kosong. Bila you jumpa 0.0 something, boleh buat lagi. You boleh continue lagi for the 6 cycle, 6 distribution. Okay, tapi dia represent the same lah. Normally kami bila nak assess you, kita nak assess your understanding. Jadi you nak buat 5 kali ke, you nak buat 7 kali, 10 kali ke kan? You repeat the same process. Ni kalau you boleh buat 5 kali dah okay, bermakna student tu faham lah proses ni kan. Jadi tu yang kami nak assess. Jadi you boleh stop bila you jumpa 0.0. Kan selagi tak dapat ni dah jumpa kan tadi kan? 0.0 nak besarkan dia jam pula kejap. Bagi balik kat sini. Okey, bila you jumpa kat sini 0.0, 0.0 kan dah jumpa 0.0 kat sini kan? Ini kan dah 0.0. That's why saya stop. 0.0. Okey, yang ni distribution number 5. Tapi kalau bila you buat distribution 5 times, masih lagi 0. Tak jumpa lagi 0.0, you boleh continue lagi. Okey, tapi kalau tapi sebab yang ni bukan masuk exam kan? As assignment kan, as assignment only, so dah boleh stop lah. Tapi kalau you pakai Excel ni, continue je lah 10 kali pun just copy paste only kan. So lagi banyak lagi accurate lah. So sebenarnya moment distribution method ni bila kita do this process, kita akan buat sampai dapat 0.0000 means equal to 0. Okay, tapi kalau dalam exam basically yang batch-batch yang dulu ada exam kan memang 5-6 kali macam tu dah cukup. Okay. Okay, so the moment that we get here is actually internal moment, and from this moment we can directly draw the BMD. Draw the BMD. So daripada moment ni macam-macam kita boleh buat. Daripada moment dekat sini kita boleh analyze each beam, each members to calculate shear value, to calculate vertical force in each support. So kita akan bila dapat vertical force kita dapat complete lah. Kita dapat completekan reaction dalam beam ni. Now kita terus dapat internal moment. So bila kita buat moment distribution method, the output which we get from moment distribution method is actually the internal moment. So internal moment belum complete. So dia ada vertical force. Okay, or vertical reaction at support. So kalau soalan tu minta untuk draw shear force diagram, kena kira dululah vertical force tu. Tapi kalau soalan tak tanya pasal shear force diagram, soalan kata okay, calculate member and moment, then draw bending moment diagram. Yang tu memang boleh terus draw diagram from this value. Okay, from this value dah boleh draw diagram. Dah boleh draw diagram from this value. Kalau soalan kata draw shear force diagram and bending moment diagram, means that you kena analyse, ambil moment-moment ni, okay, letak dalam free body diagram, element by element, one by one member, kira vertical force. Vertical force tu macam kira reaction at the support je. Okay. Lepas tu dah dapat semua, baru boleh draw shear force diagram. Tapi untuk sesi hari ni saya akan continue dengan directly draw the bending moment diagram. Okay, from this value. From this value. Okay, so okay, dah boleh zoom. Ini value yang kita dapat tadi. Allah. Ini dia. Okay. So nak draw bending moment diagram using end moment that we get from table ni, actually dia quite straightforward. Okay, quite straightforward. Kita akan start dengan tengok dia punya moment direction. Moment direction now akan follow whatever that we get in the table. Yang tadi sign convention tu semua tu sign convention untuk kita start calculation. So the value that we get from table is the real value, is the real direction that we get based on the loading given in the question. Okay, so we get MAB is positive, MBA is also positive. Okay, ni AB lah. Ni AB. Okay, so this is AB, this is BA, this is BC, CB, CD, DC. Okay, so for the moment diagram, the bending moment diagram, bending moment diagram. So saya nak draw it separately so that kita boleh nampak clear. So one by one member. Okay, one by one member. Okay, you just need to, okay, to refer to the moment direction. Moment direction untuk identify the position of the moment in the diagram. Okay, kita tengok dia punya direction. Direction dia. Okay. Okay, AB positive or negative? AB. Positive kan? Positive mean clockwise. Ingat sign convention kita positive is clockwise. So kita draw positive. Okay, BA is positive. Positive is clockwise. So this is positive. And then BC is negative. Negative is opposite. So it is negative counterclockwise. Okay, CB is positive. CB is positive, so we draw positive. Okay, CD is negative, we draw negative counterclockwise. DC is positive, so we draw clockwise. Faham ke tak faham? Okay, so kita tengok je value dalam table. Okay, and then tengok dia punya sign. Okay, letak moment diagram ikut sign tu. Okay, kalau positif sebab kita punya sign convention positive is clockwise. So semua positif tu arah dia clockwise lah. Dan semua negatif arah dia counterclockwise. So macam ni. Okay, this shows the moment position in the diagram. The moment position in the diagram means that position pertama dia dekat sini. Okay, the first position dekat sini. Okay, the second position dekat sini. Okay, yang ni position dia dekat sini. Okay, yang ni tengok pada arrow. Position dia dekat sini. Okay, this is the position. Tengok pada anak panah tu, pada arrow. Yang ni. Okay, so to draw the diagram, we just need to join the dot. Okay, join the dot. Of course, yang ni the first point, this is the last point. The first point, the last point. The first point, the last point. Okay, so since AB tu, AB tak ada loading. Tak ada loading, kita boleh terus sambung titik-titik tu lah. Okay, sebab AB ni, AB no UDL, no point load. Sekejap gimana tah? Okay. Kejap, sementara saya betulkan skrin. Okay. So ini Okay, ni. This is the first point, this is the last. Okay, first. Okay, dia macam ni. Okay, ni. Kalau you ikut step ni, draw diagram, confirm dapat full mark. Okay, so AB tu since AB ni kan dia kosong je kan, tak ada loading kan, tak ada UDL, tak ada point, tak ada anything kan. Okay, kita boleh terus dapat the BMD for AB as this. Okay, and the value is 62.475 and yang bawah tu is 125.25. So this is positive, this is negative. Okay, dah siap BMD for member AB. BMD for member AB. Okay. So next member BC UDL. Member BC UDL. Bila UDL ni bending moment diagram dia curve. Okay. Curve. So in order to identify whether the curve has maximum moment or not, yang ni memang you kena analyse beam BC, identify dia punya shear force. Lepas tu from the shear force, kena draw shear force diagram. Dah dapat shear force diagram, tengok pada shear force diagram, kena identify. From shear force diagram tu, you get trapezium or you get dua triangular yang ada intersection. Because kalau ada intersection pada shear force diagram means ada maximum moment pada bending moment diagram. Okay, without doing that, kita tak boleh identify the right one. Okay, the right one. Tapi kalau untuk tujuan nak sketch, okay, nak agak-agak bentuk dia kan, boleh buat macam ni. Okay, yang tu tak sempat bincang sekarang. Nanti kita tengok, saya buat video lah. Saya tak nak kacau waktu kelas, saya akan buat video untuk identify, untuk calculate shear force, lepas tu draw shear force diagram, lepas tu from shear force diagram kita nak identify maximum moment in the bending moment diagram. Okay, yang ni dia curve. Curve tu lebih kurang macam ni lah. Curve tu lebih kurang macam ni. Kalau ada intersection means macam ni curve dia tu. Okay, kalau ada intersection. And value ni kat tengah-tengah ni, value intersection ni, okay, we can get from shear force diagram. Yang ni kita akan dapat from shear force diagram. From shear force diagram. Maximum moment tu. Okay. Kalau dia trapezium, kita tak tahu dia punya maximum moment tau. Dia jadi macam ni je. Contoh kalau kita dapat trapezium, dia akan dapat macam ni. Yang ni kalau trapezium. Kalau triangular yang ada intersection, ada maksimum. Kalau tak ada, kalau trapezium dapat macam ni. So yang ni kalau shear force diagram trapezium. Trapezium. Yang ni kalau shear force diagram triangular. Shear force diagram triangular dapat ada intersection. Intersection pada shear force diagram ni. Ada intersection ni means ada dua triangular tu lah. Okay, kalau trapezium yang kat bawah. Kalau ada intersection in bending moment diagram yang atas tu. Okay, so yang ni point load kan. Point load means ada point load dekat sini. Okay, point load dekat sini sama juga nilai maximum moment dekat sini pun we get from shear force diagram. Tapi yang ni dia bukan curve lah. Dia bukan curve. Okay, dia dah pening dah. Sekejap. Okay, yang ni dia straight line. Okay, straight line. So value tu depending on shear force diagram. $11.50 dah. Tekak pun dah kering dah. 4 jam daripada pagi tadi. Tak boleh nak pusing dah. Panas dah dia pun. Okay. Ni. Okay. Dia macam ni lah. Lebih kurangnya macam ni. Memang macam ni lah. Ni lah jawapan dia. Okay. So value-value dia tu. Value-value dia ni kan. So dekat sini 234.25. Okay. Yang bawah yang ni 281.485. For dia dah berkelip-kelip tu. Dia panas tu. 485. 4 jam dah. 485. Yang ni pun 28, yang ni 281 juga. Okay. Dia dah suruh stop. 281.5. 281.5. Okay, 281.5. Yang ni 125.125.25 kan. Cuma yang ni lah tak tahu. Maximum moment dua-dua pun tak tahu. Kena buat shear force diagram dulu. Okay. So, yang atas positif, yang bawah negatif. Okay, ni negatif. Dan yang kedua ni, okay, yang kedua ni semua opposite sign. Opposite dengan yang ni, opposite dengan yang ni, opposite dengan yang ni. Sebab apa opposite? Sebab apa opposite? Sebab dia bila tambah dapat 0. Okay, means that yang ni negative 125. Negative 125 tambah 125 dapat 0 kat sini. Okay, yang ni negative 281 tambah 281 dapat 0 kat sini. Okay, yang ni 234 negative. 234 negative tambah dengan 234 positif dapat 0. Okay, means that kita dah close loop. Okay, this is how we draw the bending moment diagram from shear force, from member and moment that we get from table. Okay, and we cannot get the maximum moment for member BC and member CD because that one we have to analyze analyze the vertical forces first, draw the shear force diagram, and from the shear force diagram, then only we can calculate the maximum moment inside these two diagrams. Okay, this is how we analyze beam. Okay, simple beam, without settlement, simple beam using one table only. And then we draw the bending moment diagram from the moment that we get from table. Okay, this is how we draw the bending moment diagram. Okay, do you have question? Do you have question?
Okay.
Benda ni you kena practice. Okay, it is very very important for you to know. So you have to practice. So kita akan continue dengan moment shear force diagram, shear force bending moment diagram ni throughout this course. Nanti flexibility method pun can continue with shear force bending moment diagram. Stiffness also can continue with shear force and bending moment diagram. And anyway, depend on the question lah. Okay, tapi for you to get familiar with diagram, shear force diagram and bending moment diagram. So bila nanti buat analysis of flexibility method dah dapat all the reaction, boleh juga continue draw shear force diagram and bending moment diagram untuk practice a lot lah, practice so that you boleh always remember this knowledge because this is very very important. So nanti dekat dalam design you punya diagram terbalik tau. Dalam design punya diagram ini positif dekat atas, negatif dekat bawah. Okay, positif dekat atas. Analysis can be drawn negative like this or terbalik pun doesn't matter. But in design, negative we put on top. Negatif kat atas, positif dekat bawah. Okay, sebab kita from maximum moment tu, kita akan dapat detect dia punya crack. Okay, kat mana maximum crack. Then only kalau ada problem, kita boleh tahu kat mana kita nak repair lah. Okay, so the most important thing, I hope you understand the process to get the member and moment. So bending moment diagram tu is additional. Okay, it's good for you to know. And of course, bending moment diagram as a civil engineering student, structural engineering student, you should know how to draw it. Okay, so practice lah whenever you do moment distribution method. So dah ada value tu, just practice draw bending moment diagram. Okay, so that's all I think. Do you have question? Do you have question?
No.
Is it okay?
No. Okay,
Okay.
doctor.
Okay, I have actually kat sini. Sekejap, tunjuk balik. So dekat sini ada soalan, nanti saya akan assign lah. So you dah finish you punya 3 hours kan? Okay. So there are 2 questions here, formatting 1.1, formatting 1.2. Okay, formatting 1.1.2 ni untuk your exercise. Okay, untuk your exercise you boleh buat 1.1.2. And summative ni yang you have to submit. Summative ni you have to submit. So formatting 1.1, 1.2 ni nanti saya akan distribute dalam your folder. Okay, formatting 1.1 dengan 1.2 ni I will distribute into your folder. So you punya folder ada apa dekat handout. Okay, formative 1.1 dengan formative 1.2, bukan dekat homework dekat homework. Okay, dalam folder homework nanti I will distribute to you the formative. Sekejap, mana dia tadi tu? Sini. Okay, formative 1.1.2 I will distribute. Okay, you do this as your exercise, and then you have another one summative 1.1, summative 1.1. Yang ni 5% from your for your assignment. Okay, yang ni yang you kena do it well. Okay, stiffness factor, distribution factor, phase and moment, member and moment, draw and analyze shear force diagram and bending moment diagram. Nanti saya akan buat satu video untuk explain how to analyze shear force diagram, how to analyze shear forces and then draw shear force diagram, shear force diagram, and from the area of shear force diagram we get the maximum moment. Actually dah ada video-video last semester. Last 2 semester yang dah discuss pasal ni. Okay, kalau saya tak sempat buat yang baru, saya akan share balik yang previous lah. Kalau saya sempat yang baru, saya buat baru, saya akan buat yang baru lah. Okay, so that's all I want to tell today. So I hope you enjoy this session. I hope you get, okay, so this is the end of session today. I hope you get the outcome for today. So you know how to calculate member and moment, and then from the member and moment, draw the diagram. So nanti do your exercise, do it and upload, insert the document that you have done into OneNote, into OneNote. Sameti tu saya akan assign guna team assignment, so you will get notification. So okay, nanti saya akan set lah final date bila, tapi tak payah tunggu lama-lama lah, terus buat dan terus buat, so that sekarang masih fresh, belum lupa lagi kan. So terus buat dan terus submit. Okay, kalau you nak practice dulu, you boleh buat juga formative 1.1 and formative 1.2. Okay. Okay, so before we end session, tadi lupa snap picture kan? Okay, okay, saya tukar balik setting. Sekejap, meeting option. Okay, can you switch on camera for a while? Okay, for photo session. Okay, done. Okay, please switch on camera. Okay, for photo session. Okay. Okay, ada lagi? Yang lain-lain tolong buka sekejap. 1 minit je. 1 minit. Kejap, exit spotlight. Okay. Okay, about 1 minute. Please switch on camera. Kita nak take photo. Okay. Okay, 1, 2, 3. Sekejap ya. Alamak, mata pun pejam. Okay, another one. Mata saya lah yang pejam. Okay, another one. 1, 2, 3. Okay. Yang ni. Okay, thank you. Okay, thank you class. We close our session with Tasbih, Kifara and Surah Wal As.